Hello everyone, we are group 7. We are going to discuss about security bugs of two open source projects. One is Audacity and another one is KeePass. My name is Resalat Amin. In this presentation, I am going to discuss about Audacity, and here is the overview of my presentation where I have discussed about what is Audacity, security bugs, changes in code, common attack pattern enumeration and classification, impact of these bugs, workaround and security patch, and references. So first is Audacity. Audacity is a digital audio editor and recording software for Windows, Mac OS, Linux, and other operating systems. The core features of Audacity software is recording. Audacity can record live audio via a microphone or mixer, as well as digitize recordings from other media. Export and import. Sound files can be imported, edited, and combined. You can export your recordings in a variety of file formats, including multiple files at once. Sound quality supports 16-bit, 24-bit, and 32-bit resolutions. High quality resampling and dithering are used to convert sample rates and formats. Accessibility. The keyboard can be used to fully manipulate tracks and selections. A wide variety of keyboard shortcuts are available. Analysis. Spectrogram view mode is used to visualize and select frequencies. Plot the spectrum window for in-depth frequency analysis. VM analysis plugins are supported. Now security bugs. The CVE ID is 2020-11867 and severity score is 3.3, which is a base score. It means it is not severe at all. I have found several bugs in this case. For instance, by default, Audacity through 2.3.3 saves temporary files to this location, which is var/temp/audacity user. Audacity sets the permission of the temporary directory to 755. The temporary audio.au files located there can be read and played by any user on the system. 755 denotes read and execute access for everyone as well as write access for the file's owner. In this case, insecure use of the temporary directories results in information leakage. Crash on loading saved Audacity project. After saving a recorded file, when we restart Audacity software and reopen saved file, we can see it is crashed. Now we can see some changes in code where we can see that they have deleted some lines and added some lines with method and conditions. Next is common attack pattern enumeration and classification. Web logs tempering, where the weaknesses are improper input validation, improper encoding or escaping of output. Next is accessing functionality not properly constrained by ACLs, where the weaknesses are incorrect default permissions, improper authorization, unrestricted upload of file with dangerous type. Next is directory indexing, where the weaknesses are improper protection of alternate path, direct request, and protection mechanism failure. Impact of the bug. We can see it is only affected in confidentiality, which is partial, and others are none. Passive deception, incomplete disclosure, or omission are all terms used to describe partial disclosure. Now the workaround. The most straightforward solution is for Audacity to create temporary directories with 0700 permissions. However, a better solution might be for Audacity to save its recovery files in a non-world readable location, which means the user, group, and others cannot read and write in that location. The Audacity development team was notified of this vulnerability privately on 10th March 2020. In the new version, they fixed some security issues, for instance, fixed a crash when loading a saved project using certain compilers, fixed data loss when joining clips, fixed a crash with exporting resampled tracks. And here are the references of my research. The next part will be continued by my other groupmate. Thank you.
Thank you, Resalat, for your presentation. Hello everyone, I am Fahim and I'll be presenting my chosen security vulnerability for KeePass Password Safe Password Manager. Well, before starting, let's see the overview of my presentation. We'll get to know about KeePass Password Manager. We'll talk about the security exploit which is called KeePass. We will take a look at the codes and how the exploit works, impact of the security bug, workaround and security patch, and my references. So what is KeePass? KeePass was developed by Dominic Reichel and was released 18 years ago in 2003. The program is written on C++ and in the later version in C#. KeePass Password Safe is a free and open source password manager primarily for Windows. It officially supports Mac OS and Linux operating systems through the use of Mono. Additionally, there are several unofficial ports for Windows Phone, Android, iOS, and BlackBerry devices. KeePass stores usernames and passwords and other fields including free form notes and file attachments in an encrypted file. This file can be protected by any combination of a master password, a key file, and the current Windows account details. By default, the KeePass database is stored on a local file system as opposed to a cloud storage. Overview: KeePass has excellent import-export features. It can import from over 30 other most commonly used password managers. It has a multi-user support, auto-type drag and drop support across the popular browsers. It has a password generator and synchronization function, which supports two-factor authentication and has a secure desktop mode. KeePass supports a variety of plugins. It can use a two-channel auto-type obfuscation feature to offer additional protection against keyloggers. Why KeePass? In present time, we have to remember many passwords at once for different accounts. We need a password for a lot of websites, our email accounts, our web server network logins, and etc. Also, everyone should use a different password for each account for better security. If we use only one password everywhere and someone gets this password, we will be in big trouble. The thief would have access to all of our accounts. KeePass can store all your passwords in one database, which is locked with a master key. So we only have to remember one single master key to unlock the whole database. Database files are encrypted using the best and most secure encryption algorithms. So, KeePass is free and you have full access to its source code. It's open source and which prevents backdoors. You can have a look at its source code and you can check yourself if the security is implemented correctly or not. If you want, you can use any other encryption algorithm to your needs. KeePass is OSI certified. OSI certified is a certification mark of the open source initiative. Starting to use KeePass has a slight learning curve. If anyone is interested, here's a great video explaining everything you need to know about using the password manager. Security features of KeePass. KeePass relies on a AES 256 encryption to secure its password database like most other password managers, while KeePass defaults to an AES 256 algorithm which can be changed to a ChaCha20 256-bit key algorithm in the database setting anytime. Runtime security. According to the utility's author, KeePass was one of the first password management utilities to use security enhanced password edit controls. In this case, this is one called C-Secure Edit X. The passwords are protected in memory while KeePass is running. On Windows Vista and later versions, passwords are encrypted in process memory using Windows Data Protection API, which allows storing the key for memory protection in a secure, non-swappable memory area. Offline security. Access to the database is restricted by a master password or a key file. Both methods may be combined to create a composite master key. If both methods are used, then both must be present to access the password database. KeePass version 2.x introduces a third option dependency upon the current Windows user. KeePass encrypts the database with the AES 2FISH or ChaCha20 symmetric cipher, where the first two are used in CBC PKC S7 mode AES, AES is the default option in both KeePass edition, which can be changed later in the settings. Popularity. A 2017 Consumer Reports article described KeePass as one of the four most widely used password managers, alongside 1Password, Dashlane, and LastPass, being popular among tech enthusiasts and offering the same level of security as non-free competitors. These are some of the security vulnerabilities of KeePass. If we look at some of them, like the automatic update feature that allows man-in-the-middle attacker to execute arbitrary codes, or the entry details view function in KeePass version 1.32, which inadvertently decrypts certain database entries into memory, which may result in the disclosure of sensitive information. Based on these vulnerabilities, there are popular projects on GitHub that explore and exploit this and can successfully retrieve user information and the master keys. These are the popular projects: KeyFirst, KeyThieves, and Lasagna. The KeyFirst exploit. KeyFirst allows for the extraction of KeePass 2.x password database information from memory. This leads to revealing usernames, passwords, imported files, URLs, and various nodes. The KeyFirst exploit works on KeePass 2.28, 2.29, and 2.30 running versions on Windows 8.1, both in 32 and 64 bits. Let's look at how KeyFirst works. Here are the main code files that KeyFirst uses to exploit the KeePass runtime process. KeyFirst get the current process ID from Windows runtime process of the KeePass exe process. KeyFirst uses DLI injection to execute code within the context of a running KeePass process. The C# code execution is achieved by first injecting an architecture-appropriate bootstrap DLL. This spawns an instance of the .NET runtime within the appropriate app domain, subsequently executing KeyFirst DLL, which is the main C# payload. In the KeePass process heap, it locates the pointers to some required sub-objects and uses reflection to call an export method. The KeyFirst DLL uses CLRMD, which is the Microsoft Diagnostic Runtime DLL, particularly on this object, KeePass Data Exchange, in order to export all existing passwords to disk. This is the export function the process uses. And finally, KeyFirst allows for the extraction of password database information from the memory. All the information is dumped into a CSV file in AppData. Impact of the exploit. Private information is exploited. Personal data is lost to the adversary. Email and contact information is compromised and may lead to scam calls and inappropriate situations. Banking, credit card information is up for grabs for the exploiters. Most of the people are sensitive about their health info, and it may also be compromised by the exploit. Workarounds. Protection against generic spyware can be implemented. For example, two-channel autotype obfuscation is a way to protect autotype data from keyloggers. These are good workarounds from the exploit we talked about. KeePass OTP is a GitHub project giving the feature of two-channel autotype obfuscation, and the plugin tray TOTP also can help in this case. Both of these will help in the situation of compromise. If the master key is lost and someone is accessing from an unauthorized source, this will ask for a second authentication and prevent the exploit from happening. And sometimes just running a good antivirus software is a simple and most effective solution. Keeping your operating system updated is important, and it will prevent harmful exploits in most of the cases. Here are my references for the presentation and project work. This is the end of my presentation, and thank you for listening.